Hello class, today we'll be doing your guided lab 10 for IS 2010. To find this assignment, please go to your week 14 module and find your guided lab 10 assignment. The skills that we'll be going over in this Excel lab is rules of addition, rules of multiplication, and contingency tables. So we will be working with probability for this week. As always, go ahead and download your workbook and let's go ahead and begin. Once we have it open, let's go ahead and change our file and save it in a place with the correct label, UID, and we're ready to begin. Starting off with rules of addition, let's go ahead and go to that worksheet, and let's go ahead and select cell C7, and we're going to do the probability of going to the movies, going to a concert, playing sports, or staying at home for a survey of 300 students about their favorite weekend activity. So before we do that, I will go ahead and do the auto sum for here. And we're going to drag it over to our C column. And let's go ahead and type in this probability. So this probability is going to be B7 divided by our total. And we're going to absolute this. Let's say at 0.3. And the next thing we want to do is just drag down our formula down. And we should get our probabilities right there. Okay. Next step that we want to do is that we want to calculate the probabilities of students either liking movies or concerts, sports or stay home, movies, sports, or movies, concerts, or sports. So for the result of this, we just want to do a formula. So with equal sign, movies or concerts. So let's go ahead and select movies plus concerts. That'll give us our probability that half of the students would like to go to the movies or go to a concert. Next is sports or stay at home. So we're going to do C9 plus C10. We're going to get a 50% like before. Next, what we want to do is movies, concerts, or sports. So we're going to do an equal signs here. We're going to do movies plus concerts plus sports. There we go. Next thing we want to do is that we want to do general rule of addition next. So a survey was conducted with 400 students about extracurricular club participation. Students could join multiple clubs, and this is the results as showed. So we have the science club, the art club, and students that are in both the science and art club. So we're going to set this up like how we had before. So we're going to auto sum, drag it over. Next thing we want to do is that we want to go ahead and do this, divided by this one, absolute that denominator, and this will be our probabilities. Okay. Now, the next thing that we want to do is we want to calculate the probability of a student being in both the science and art club. This is going to be a little bit different. So we have one section here that does account for both science and art, but we also have students that are a part of the science club and the art club, but separately. So what we want to do is we want to go ahead and do equals C18 plus C19, and then we want to subtract by our both science and art, and this will give our resultant of 0.7 of the students will be both science and art in art. Okay, moving on, let's go ahead and go to rules of multiplication. First thing we want to do is what is the probability of rolling a 4 on a die and flipping heads on a coin? Okay, so what we want to do is for rolling a die, we want to say is equal to 1/6. To flip a coin on heads, it is 50%, so 1/2. And now we want to calculate the probability of both of these occurring in sequence. So we want to go do an equal signs times our flipping the heads. So this is our resultant percentage or probability of doing these two actions. Moving on, let's go ahead and do the probability of not rolling a 6 and flipping a tails. So this one right here would be equals to 5, 6. This one right here is going to be the same as before, 1/2. And we're going to do the same thing here. We're going to times these through. We're going to get 0.417. Okay. Now we're going to do grabbing a red marble from a bag and with replacement. Okay. So we have a total of 10 balls, and we have 5 red marbles and 5 blue marbles. So the probability of grabbing a red marble at first is going to be 5/10. So we could just simplify that down to 1/2. And then the probability of drawing a red after a red, this is just going to be 1/2 again, or 5/10 again, because we are replacing, putting back the ball, whatever resultant we had beforehand, and putting it in. So this one's actually going to be 1/2 times 1/2, I believe. Let's go ahead and double check this. C15. Yep. Okay, so you're just going to times it by 1/2 times 1/2, because they both have a 50% chance of being red. Okay. Moving on, we're going to do general rule of multiplication. Scenario 1. Using a standard, fair, and complete deck of 52 playing cards, calculate the following of these next 3. What is the probability of drawing an ace followed by the king without replacement? So to draw an ace, there are 4 aces, so we're going to say equal 4 divided by 52. Next thing we want to do is that we want to say how many, calculate the probability of king or ace. So this one is going to be 4 divided by 51. There you go. Now, probability of ace and king. This one's going to be equal to this one times the probability of a king followed by an ace. There you go. Moving on, let's go ahead and do what is the probability of drawing 2 hearts in a row without replacement. So in the deck, there are 14 hearts, so it's going to do 13 hearts, so 13 divided by 52. And then the probability of drawing a heart right afterward is equal to 12 divided by 51. And it's 51 because we are not replacing the initial card that we draw. Now the probability of both hearts being pulled, this plus, times that. There we go. And there's our probability. Okay. Moving on, what is the probability of drawing a red card followed by a black card without replacement? So in the deck, there are going to be 26. So let's go ahead and do 26 of red. And followed by this, there are 26 black, but there are 51 cards. So let's do that. The probability of these two happening in sequence is 0.255%. Okay. Moving on. A science fair judge must select 2 winners from 5 projects. The projects are divided by category. There are 2 projects in robotics, 3 projects in environmental science, and we also have, once a project is selected, it cannot be chosen again, so there is no replacement. So the selections are dependent events. Event A, we want to go ahead and calculate these. So event A, selecting the robotics project first. Event B, selecting an environment science project given that a robotics project was already selected. So the first thing we want to do is that we want to compute event A, in which a robotics project was first. So this one's going to be equals to 2 divided by 5, I believe. Yes. Compute event B is after A. So we're going to do can't be robotics again. So it is going to be 3/4. So 3 divided by 4. There you go. Because we lost one of the robotics one. Now, applying both this, we are going to be doing C43 times 5, C44 for our probability of 0.3. Okay. Moving on to our last worksheet, let's go ahead and go to contingency tables. First thing we want to do is that we want to fill out these totals here. So let's go ahead and do that real fast. So just do auto sum. And we're going to drag this formula over to the right. Okay. Now we want to given the contingency table above, what is the probability that a randomly selected person is either one of these 6 things? So exercises regularly, this is going to be equal to 90 divided by our 200. Does not exercise is going to be our 110 divided by our 200. Uses social media, so this is going to equal to our 120 divided by 200. Does not use social media, so this is going to be our 80 divided by 200. Exercises regularly and uses social media, this is going to be equal to 50 divided by our 200. And the next one is does not exercise and does not use social media. So use this one. It's going to be 40 divided by 200. Okay. With that, that should be the end of the Excel lab. So let's go ahead and turn this in. Should be saved. Yep. Okay. Today was a pretty quick lab, so hopefully you guys followed along just fine, and I hope you guys have a great day. If you have any questions or concerns, please email either me or the professor or your respective TA, and have a great day.